Good morning, you guys. Hi, it's Miss All Day. I hope you guys are doing well on Thursday, April the 30th. I really appreciate your hard work. I want you to know that. I know that this has been a transition for us all, but especially for you because you have so many classes to juggle each day. So I thank you so much for keeping up with your work. We're on the downhill slide of it. Today and tomorrow, we're going to do 13.3. I'm breaking it up into two sections. So the first section, I'll cover problems 1, 2, and 3, and then you'll do got it problems 1, 2, and 3. And then on Friday, I'll cover problems 4 and 5, and you'll do got it problems 4 and 5. So I'm going to go ahead and do it all in this video. That way, if you want to just do it and not have any work for me on Friday, you could take a picture of the got it problems 1, 2, and 3. And then the got it problems 4 and 5 and upload them separately to the two assignments. All right, so we're going to go ahead and get started. Now, this is section 13.3. It covers Thursday and Friday, and then we're going to do 13.5 on Tuesday. On Monday, we're having a mid-chapter test, but then on Wednesday, you're going to review and then test again on Thursday. So this is the second to last concept that's new, okay? And then the rest of the time, we're going to be reviewing to make sure you keep all those concepts in your head because we know you still have to take the EOC, and I want to make sure that you hadn't forgot the stuff we learned earlier in the year. All right, 13.3, permutations and combinations. Okay, so we're going to start with day 1, which is 4, 30, 20. All right, I'm going to pose a question right here, but I'm not really going to want you to answer it. You can answer it where you're at, but you don't have to answer it right now. How many different possible ways can you order a drink, a side, and some kind of burger from your favorite burger restaurant? Sometimes there are so many possibilities that listing them all is not practical. You can use counting techniques to find all the possible ways to complete different tasks or choose items from a list. So this is called the fundamental counting principle, okay? The fundamental counting principle says that if event M, let's just say it was how many possible lunch specials, okay? M. We're going to say that if event M occurs M ways and event N occurs N ways, that event M followed by event N can occur in M times N ways. So let me go back and correct what I just said. If we're doing event M and we're doing event N, those are two separate events that make one event. Okay, so in this example here, event M is how many different entrees there are for you to choose from. Let's say you're at, what is the one called? Five Guys and a Burger. And let's say there's 4 different burger entrees that you could choose from. Okay. And then let's say you look at the drinks and there's 6 different drinks. You know, you can get tea, Coke, lemonade, what else? Water or punch. Okay. You would take 4, which is the number of entrees, and you would take 6, which is the number of drinks. And when you multiply them, you have 24 possible lunch specials. So when you think about it, when you go into a restaurant, there are so many different, what's the word I'm looking for? So many different possibilities of what you could order when you walk into a restaurant. All right. So here's an example here. Suppose that you're choosing an outfit. By first selecting, you're going to select either blue jeans or black pants. Okay, so here's the blue jeans and here's the black pants. Okay, so that's the pants you're going to choose. Then select a red, green or blue shirt. Okay, so here we have, if I selected blue jeans and I picked red, green, or blue, I could have red shirt with jeans, green shirt with jeans, and blue shirt with jeans. All right, now, with the black pants, I could pick a red shirt, a green shirt, or a blue shirt. Then I would have a red shirt with black pants, a green shirt with black pants, and a blue shirt with black pants. And you see how many different combinations there are. 1, 2, 3, 4, 5, 6. Now, a lot of the times, people will write it like this. So we're going to say blue jeans with a red shirt, blue jeans with a green shirt, blue jeans with a blue shirt, black pants with a red shirt, black pants with a green shirt, and black pants with a blue shirt. And let's go ahead. I'm going to erase the B for blue jeans, and I'm just going to put a J for jeans. All right, that's called your sample. This over here is called your sample space, and this right here is called your sample space. So this is a tree diagram. And if you remember back whenever you did factoring, that was also kind of like a tree diagram, okay? Except this tree diagram is going sideways. You could do it going vertical. This one's going horizontal. When you had like 36 was 6 times 6, and then 2 and 3, and then 2 and 3. 2 squared times 3 squared. That's a factoring tree. So it's kind of the same thing in a way, the way it looks. So the tree diagram shows the possible outfits you can choose. For M, that's pant choices. For N, that's shirt choices. So really all you had to do was multiply 2 times 3 to get 6. You didn't have to write it all out. So you can use the fundamental counting principle for situations that involve more than 2 events. All right, let's do our first problem. We have a deli menu up here. We see there's sandwiches, there's side items, and there's a drink. So a deli offers a lunch special. And if you choose one from each of the following types of sandwiches, side items, and drink choices, how many different lunch specials are possible? All right, so let's think about it. How many possible sandwich choices are there? All right, there's 6. You're right. All right, how many possible side items? All right, 4. That's correct. And then how many possible drinks? All right, 5. All right, so multiply that and tell me what you get. All right, you should have gotten 120. Okay, and so that's 120 different possible lunch specials. Pretty easy, right? Fundamental counting principle. You can do this in so many different ways. Like if you're packing stuff and you want to go on a trip, but you don't want to pack too much, but you want to have like, you'll wash clothes while you're gone. So you could have like 4 pairs of pants and maybe 2 pairs of shorts, and then 3 short sleeve shirts and 4 long sleeve shirts. And you could see how many different combinations you could actually have. All right, so you're going to do the got it problem, number 1, on page 837 in your textbook. So I did it the way I've been doing it for this chapter. And if you look at the very last page, this is the got it problem number 1. Okay, so it's going to pattern what we just did. All right, and this is day 1. All right, let's go ahead and go back to problem number 2, which is on the next page. Just going to do some reading because I need you to be reading it too, because when you read it, you'll understand it more. A permutation is an arrangement of items in which the order of the objects is important. A permutation. This is very important, that order matters. A situation where order matters is like who comes in first, second, or third place in a race. The order matters, whether you're first, second, or third, or 10th. The order matters. All right. You can use the fundamental counting principle to find the total number of permutations. So we can use what we just did to find out about permutations, even though order matters. Now think about what we just did does not matter about order. I could have done 5 drinks choices times 4 side items times 6 sandwiches, and I'm still going to get the same answer. So that order did not matter, okay? Suppose you want to find the number of ways to line up 4 friends. There are 4 ways to choose the first person. 4 ways. There are 3 ways to choose the second person. There are 2 ways to choose the third person. And there's only 1 way to choose the last person. So there are 4 times 3 times 2 times 1, 24 permutations. There are 24 ways to arrange your friends. Okay. Now, I had posted yesterday this word called factorial. Now, just so you know what a factorial is, it's an exclamation point. Okay? You can use factorial notation to write 4 times 3 times 2 times 1. And you write it 4 factorial. And you read it that way. For any positive integer, n, if it's n factorial, it means you're going to take the first number, 4 choices. You're going to multiply it by 1 less than the first number, which in this case was 3. 4 minus 1 is 3. Then you're going to multiply it by n minus 2. So that would have been 4 minus 2, which is 2. And then you're going to multiply it by n minus 3. 4 minus 3 is 1. So you see, you still would have got 4 times 3 times 2 times 1 if you followed that algebraic expression. Okay? 0 factorial, just so you know, is going to be equal to 1. Just like, I don't know if you remember this, 5 to the 0 equals 1. So 0 factorial equals 1. Okay? All right, now I have this little video here to show you how to do factorials on the calculator, but I'm going to go back to that, and I'm going to go ahead and do problem 2 first, because you need to be able to do it without a calculator, just in case somebody doesn't have one, and just so you know how to do it, because sometimes in Algebra 2 you're able to use a calculator, and sometimes you're not. All right, finding the number of permutations. This is on page 837. You don't have to turn there really, because I have everything right here on the notes. Music. You download 8 songs on your music player. If you play the songs using the random shuffle option, how many different ways can the sequence of songs be played? All right, so the first song is played, and now I only have 7 more choices for the second song. Okay, so 2 songs have been played, so 8 take away 2 is 6. Okay, so every time I play a song, that's 1 less choice of what I'm going to play next, right? All right, so this right here, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 8 factorial. Okay? Now, I want to show you in your calculator now how to type that in. All right, so we're going to watch this. Let's see if I can click on that. It's taking a minute to start. Sorry about that, you guys.
Lil Dicky.
I'm Lil Dicky.
Lil Dicky.
Call me Dick.
Yes, I know that I'm a rapper at the end of the day, but I think it's time you knew me by my
Add, sorry,
government
you
name.
guys.
In this video I'm going to show you how to do factorials in TI-30X. A lot of people on the internet are very confused about how to do this. The reason is, if you look, there is no factorial key here, that you can't find an exclamation mark anywhere on this calculator. As it turns out, the company have, for whatever reason, decided to hide it away in this probability function. So I'll show you where to find that. So let's just do 3 factorial. In this video I'm going to show you how to do factorials in TI-30X. Look, there is no factorial key here, that you can't find an exclamation mark anywhere on this calculator. As it turns out, the company have, for whatever reason, decided to hide it away in this probability function. So I'll show you where to find that. So let's just do 3 factorial, quite simple to understand. 3 times 2 times 1 is of course 6. So if we press 3 here, it's 3 in the display. Then you've got this prob button, PRB. So you press that and you get into this, so that's your permutations, combinations, and some other functions on the next bit. But we want this exclamation mark. So underline that exclamation mark, press enter. So we've got 3 factorial, press or enter or equals, and you get 6. So that's how you do factorials. I'll show that again quickly. Clear that. So let's go 5, probability, underline, factorial, enter, and then equals, and we get 5 factorial, which is 120. So that's how you do factorials on your TI-30X. Hopefully it's been helpful to you. You've found that hidden function, and thank you very much for watching.
All right, sorry for the little bit of technical difficulties there, but you saw how to find that now. And so what we're going to do now is we're going to download our 8 songs on our music player. So we're going to do 8 factorial in our calculator. So go ahead and get your calculator, turn it on, clear it out, hit the 8 button, go to the PRB. That's your probability button. It's right underneath DRG. It's to the right of the log button, and it is diagonal to the second button. So hit that button, and then hit the arrow button, and go over 2 spaces until you see the factorial button, which is an exclamation point. Hit the enter sign. You should see 8 factorial in your calculator. Hit the equal sign again, and that's going to be 40,320 different ways to randomly play the 8 songs. All right, so we're going to write that out. So remember, different ways to randomly play the 8 songs. All right, so you have a got it problem number 2. That's found on the very last page. Here's got it problem number 2. We already looked at got it problem number 1. All right, so we're on our last concept for day 1. Right underneath problem number 2, where it says suppose. Suppose you want 3 songs to play at a time from the 8 songs that you just downloaded. You want there to be 3 songs to play at a time. There are 8 ways to select. There are 8 ways to select the first song. There are 7 ways to select the second song. And there are 6 ways to select the third song. By the fundamental counting principle, you just have to multiply the 8 ways for the first song, the 7 ways to play a second song, and the 6 ways to play the third song. Okay? You would get 336 ways. You are not using the factorial button here. Remember, the factorial button is when you are going to multiply all the choices. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? That's finding the number of permutations where order matters. All right, we'll go back up here for a minute to the fundamental counting principle. And remember, the fundamental counting principle has to do with just multiplying them any way you want. Okay? All right, so let's go back to our problem here. Permutation notation. The number of permutations of n items of a set arranged r items at a time. All right, so if you notice when you went to the probability in your calculator, I want you to go there again. Click the clear button. Go to the PRB button. Do you see NPR right there in your calculator? It should look something like this: an N, a capital P, and an R. Look right here. Same thing. So I'm going to show you how to use that button too today. All right. So if you're going to show me permutation notation, the first thing is the P stands for permutations. Okay. The N stands for the items of a set. So like you had 8 songs. So N would represent your 8 songs. Okay. R stands for how many items at a time. So for R, how many songs did you want to play at a time a while ago? You wanted to play 3. So that's where you get the 3 from. All right, so let's walk through this. You do n factorial. So you're going to do 8 factorial. Then you're going to do 8 minus 3 factorial. And you're like, well, I already know that's 5. But this is showing your work on how you get the 5. Okay? So 8 factorial over 5 factorial. If I wrote out 8 factorial, it's going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If I write 5 factorial, it's 5 times 4 times 3 times 2 times 1. Okay? And then think about it. This is a fraction. You can go cancel out the numbers that are the same in the numerator and the denominator. And you have 8 times 7 times 6. Which is what we already said above. I'll circle this in blue. We had already said above that that was pretty much the fundamental counting principle. Okay? Now, we didn't want to know how many ways I could do all the songs in order. We only wanted to know 3 songs at a time. What kind of order could they be in? All right, so that was 8 times 7 times 6, which was 336 different ways. All right, so we're going to find the permutation. Look at problem 3. The environmental club is electing a president, a vice president, and a treasurer. Order matters. Okay, this is a permutation. Order matters. How many different ways can the officers be chosen from the 10 members? Okay, so we're going to start off by putting it in this form. The P, the N's on the left, and the R's on the right. Think about it. N comes before R in the alphabet. It's N, O, P, Q, R. So they're in order, okay, if you forget. All right, so my P stays my P. All right, my N is going to be the number of people I'm choosing from. So that's going to be 10. So I'm going to put N equals 10. I'm going to put it where the 10 goes. And then my R is going to be, okay, well, how many do I need? I need just 3 of them. Okay, president, vice president, treasurer. I need 3. I need to choose 3 for office. Okay, so you're going to do 10 factorial. You always do the first one you wrote. It always goes first. So it goes in the numerator. Okay. All right, next, in the denominator, you're going to do 10 minus 3, and that's going to be factorial, okay, because you have 3 that you want at a time. You only want 3. The rest of them are just going to be members. You're just trying to choose officers. All right, so this equals 10 factorial over 7 factorial. I'm going to show you how to do this just in case you don't have a calculator, and then we're going to try the calculator out. So that's 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. Okay, all over 7 times 6 times 5, 4, 3, 2, 1. You can see how I wrote them. I automatically know I'm going to be canceling all these out, right? So really, if you didn't have a calculator, to find the probability of this event, you're going to multiply 10 times 9 times 8. So go ahead and do that. You should have got 720, right? 720 ways that the 3 of the 10 members could be chosen as officers. 720 ways that 3 of the 10 members could be chosen as officers. Ooh, just enough room. Now, I want you to go to your calculator. Press the clear button. Press the probability button, PRB. Okay, do you see the NPR? Okay, we're going to go to that in a minute. So press the clear button. You type in the 10 first. So put 10 in. Press the probability button. It's under NPR. So you're under the right one. So just press the equals button. And now press the 3 and press equals. You should have got the same thing. So if you notice, the 10 is taking the place of the N. And then when you push the NPR button, the 3 is taking the place of the R. So you have 720 ways. All right, so now you're going to do the got it problem in your textbook on page 838, but it's back here if you want to find it back here. Here it is. If you want to stop the video now and just do those and upload it, that's fine. I'm going to keep going, and I'm going to do tomorrow's lesson, okay? So this is day 2, but I'm still in the same section. All right, so day 2. This is going to be for May the 1st of 2020. This is your second to last new material lesson. You have one more new material, and then we're done with new material. All right, we talked about permutations, okay, and we talked about how with permutations, order matters. It matters the order you put them in, okay, so it matters whether or not you're going to be the president, the vice president, or the treasurer. That matters, okay. It doesn't matter, using the fundamental counting principle, what order or what place you're going to put your food, your drink that you got, your side item, and your burger. They're all right there. It doesn't matter which one you order first or second or third. You're going to be eating it all anyway, okay? So the order doesn't matter. So a combination is a selection of items in which the order is not important. So suppose you select 3 different fruits to make a fruit salad. The order you select the fruits does not matter. They're all going to go in the same bowl. All right, so here's combination notation. Now notice right here, when you hit the probability button a while ago, you should have saw that. A combination, okay, the number of items, okay, and how many you're going to choose at a time. Okay, so the number of combination of n items chosen are at a time. Okay, it looks very, very similar. Okay, now yesterday, remember, ours looked like this. It was P, N, and R. Okay, so remember what we did yesterday. I'm going to erase some of this. Right here is what we did. Okay, we did n factorial over n minus r factorial. Order matters. Okay, all right, let's look and see what we're going to do today. Look right here. N factorial over n minus r factorial. Do you see the difference? We have an r factorial that is still in the picture. Okay, because you're going to have more ways of doing something when order doesn't matter. Okay, so let's look at this example. Let's say we have 9 items, okay? 9 items. So we're going to do 9 factorial. And we want to put, let's say it's 9 people, and let's say we want to put them in order. I want to take 4 and put them in order, but it doesn't matter the order because we're all just lining up to get a drink of water. Okay, but 4 at a time. All right, so you're going to do the 9 minus 4 factorial. Okay, and then you're going to do the 4 factorial. So this 4 is kind of used twice. It's used as 4 factorial, and then it's used as 9 minus 4 factorial. So think about it. 4 plus 5 is 9. That's an easy way to look at it. But you have to make sure you're choosing the right number combinations, okay, if you do a little short step. Because if you choose a 4, which is you have to choose a 4, then your only other choice is a 5. So if you wanted to short step it, I'm sure some of you already see that. All right, so now 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 5 factorial is 5 times 4 times 3 times 2 times 1. And 4 factorial is 4 times 3 times 2 times 1. So if you look at this, before we were able to cancel the smaller numbers. But look at here. I'm still left with more numbers now. Okay, so I can get rid of the 1 because that doesn't change anything. But you see down here why it's simplified to 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1. All right, and I guess I really said earlier that you're going to have more choices, but that was wrong. You're going to have less choices because it doesn't matter if you have 4 people in line, okay? Look at my lovely people. It doesn't matter if Joe and Bob and Susan and Nellie, if you chose those 4 people and you don't care which order they're in, they're all going to get water or they're all going to the restroom. Okay, so that's one choice. So you're going to have fewer combinations because it doesn't matter the order. So I had to correct myself on that. Sorry, you guys. I do make mistakes, and you've probably caught some in my videos. Just me not thinking, trying to make the video as short and concise as I can for you. All right, problem 4, using the combination formula, reading. Suppose that you chose 4 books to read on a summer vacation from a reading list of 12 books. How many different combinations of the books are possible? Now think about it. So you can tell the difference when you use a permutation and when you use a combination. It doesn't matter. If you have 4 books sitting out on the table, it doesn't really matter the order you're going to read them in if you're just going to read them all summer long. Okay, so combinations, order does not matter. All right, so let's do C. how many choices of books do I have? That's my first number. That's the number of choices. And then what order am I going to put them in? Or rather, how many do I want to choose for this situation? I'm going to choose 4 books to read. All right, so I'm going to do 12 factorial, right, over 4 factorial times 12 minus 4 factorial. All right, so 12 factorial over 4 factorial, and 12 minus 4 is 8 factorial. All right, let's see what this looks like. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, now I'm going to do 8 factorial. 8, 7, 6, 5, 4, 3, 2, 1. I'm going to put that in parentheses. And now I'm going to do 4 factorial. 4 times 3 times 2 times 1. All right, so we can see that all these are going to end up canceling out. And I don't really need the 1. So for a combination of 12 books, and I want to read 4 of them, how many different combinations? It's going to be 12 times 11. Sorry about that. Got ahead of myself. 11 times 10 times 9, all over 4 times 3 times 2. Now, you know I'm a cancel happy person. So if I was really doing this problem without a calculator, I would probably say 2 goes into 10, 5. 4 goes into 12, 3. I'm done with that one. Done with that one. 3 goes into 9, 3. So if I multiply 3 times 11 times 5 times 3, I want you to figure out what that answer is. Okay, go ahead and work that out. What, 15 times 33? Okay, we got our answer. All right, now I want you to put it in the calculator and double check your answer. So hit the clear button. You're going to put the 12 in first, the number of books you have to choose from. Then hit the probability button and hit the arrow button and go over to the, I'm going to do this in black, go over to the NCR button. Okay, hit the equals button, plug in the 4 books that you want to read, press the equals button, and hopefully you got 495 books. So you need to be able to do it with the calculator and without the calculator so you know how to use those buttons. All right, so that's our got it problem number 1. That's our got it problem number 4. Here is the one you'll do for homework. That was just problem number 4. Okay, now we're going to move on to our last concept for today's lesson, problem number 5. To determine whether to use the permutation formula or the combination formula, you must decide whether order is important. So with a permutation, order matters. With a combination, order does not matter. All right, so we're going to identify whether this is a combination or a permutation. All right. A college student is choosing 3 classes to take during the first, second, and third semesters from 5 elective classes offered in his major. How many possible ways can the student schedule the 3 classes? All right, so for this problem, order matters because if you have 5 courses, let's say these are electives. So let's say one is sociology, one is psychology, there's this class called educational psychology. Let's say you want to be a teacher. Let's say there's one called children's literature that you'd like to take before you get, and let's think of one more that you might want to take. We'll just call it human relations. Okay. And if you chose human relations, educational psychology, and children's literature, those are the 3 that you're going to be taking during one semester, or maybe one each semester. Okay. All right. So that's just kind of what they mean by electives. Electives are things you don't have to take, but you know how that is at high school. It's the same thing in college. All right. So order matters. So we're going to do permutation. I'm going to choose from 5 courses. Okay. And I want to take three of the 5 courses. Okay. So we're going to do 5 factorial. The first number always goes up top. And then when you're doing a permutation, you're going to subtract those 2, the N and the R. So it's going to be 5 minus 3 factorial. So we know that that's 2 factorial. Okay, if we're going to write it out, we would write it out like this. 5 times 4 times 3 times 2 times 1. And then 2 times 1. I like to write it down there so I can cancel. Okay, so basically 12 times 5, which is 60, right? There's 60 different ways that the student can schedule the 3 classes. Now go to your calculator, clear it out, type in 5, hit the probability button. I'm already on permutations, so I'm leaving it right there. Hit the equals button, hit the 3, press the equals, and that just double checks you 60 ways. All right, a jury of 12 people is chosen from a pool of 35 potential jurors. How many different jurors can be chosen? Now, when you choose a juror selection, it doesn't matter what order you choose them in because they're all in one group. All right, so this is a combination where order is not important. So combination, we have 35 potential jurors, so that's my N. And then how many am I choosing? They said I'm going to choose a jury of 12. All right, so we're going to do 35 factorial over the 12 factorial times the 35 minus 12 factorial. All right, so let's see what this will look like. 35 factorial over 12 factorial and 13 factorial. All right, this one we're going to do in our calculator only. And you see why. Got to be real careful with this one though, okay? So we're going to hit 35. We're going to go to the probability. We're going to go over to the combination. I'm going to hit that one. So now I just have to put in my 12. So I'm going to put in 12. I'm going to hit the equals button. And you're going to see why I didn't want you to have to do this one by hand. Okay, so we're going to have 834,451,000 possible juries. Okay, of 12 people. So go back to this one and let me explain to you real quick before we close out why order matters in this one. It matters whether or not you have psychology at 8 o'clock and human relations at 10 o'clock and sociology at 4 o'clock. Order matters because you're going to be planning your day around your classes and you don't really want them to be so far apart like that. All right, so now you're going to do the got it number 5 problem. Okay, I put down on the bottom some optional assignments for day 1 if you want more practice. For day 2, if you want more practice. I would not do them because just so you know, chapter 13 is not on the EOC. But if you want more practice so you do well on the test, then you can do them. And I'll give you a bonus if you do, if you're my student. All right, you guys, have a great day. I will not talk to you again until probably Monday. Okay, I think we'll have a Zoom meeting on Monday. All right.